That star is called K2-18, a cool red dwarf in the constellation Leo.
Circling this star is K2-18b, a sub-Neptune exoplanet about 2 to 3.
K2-18b is roughly 8 to 9 times Earth's mass and over twice our planet's radius.
Instead of a rocky world with thin air like ours, it may have a deep ocean hidden under a thick,
The planet was first discovered in 2015 by NASA's K2 mission as tiny dips in.
Every transit gave us another hint about its size, orbit, and temperature, but not enough to say what its atmosphere was made of.
Then came the James Webb Space Telescope, designed to read the fingerprints of molecules in exoplanet atmospheres across the universe.
Webb doesn't see planets directly. It studies the starlight passing through their atmospheres during a transit, splitting that light into a spectrum full of chemical clues.
Certain gases absorb specific colors, leaving time bites in the spectrum, patterns that can reveal water vapor.
In 2023 and 2024, Webb turned its instruments toward K2-18b, collecting some of the most detailed.
Those observations revealed signatures of methane and carbon dioxide in its atmosphere, with less ammonia than expected.
That combination suggested a hydrogen-rich atmosphere over what might be a global ocean world, a new class of potentially habitable environments.
For astronomers, this was already big news. We were no longer just detecting hot Jupiters and frozen giants, but probing.
But there was another feature in the data: small, subtle, and harder to explain with the usual atmospheric suspects.
Team members from Cambridge and elsewhere found that one way to match this feature was with molecules like dimethyl sulfide. On Earth, DMS and DMDS are almost entirely produced by life, mostly marine phytoplankton in our ocean.
The signal in K2-18b's atmosphere reached about a 3 sigma significance level, roughly 99.7. In statistics, 3 sigma means the odds that this feature is just random noise are about 3 in 1,000.
Some headlines jumped ahead, talking about a near-certain ocean world teeming with life, but the actual science is more careful and more interesting. The scientists themselves describe these molecules as tentative, needing more data and more analysis before anyone can claim life with confidence.
The first question is whether the detection is robust. The second is whether any non-biological process could produce those covered.
Follow-up mid-infrared JWST data strengthen the case that something like DMS or DMDS is present, but
other teams have reanalyzed the same data, some supporting the interpretation, others arguing that the signal may be weaker or that alternate models fit just as well.
That is how science works at the frontier. You tweak the models, test new assumptions, and see which.
At Universe Unlocked, we want to follow that process honestly, being excited about potential biosignatures.
Let's step back and look at the world itself. K2-18b orbits its star once every.
But its host is a red dwarf, smaller and cooler than the Sun, with redder light and potentially more stellar flares that can affect a planet's atmosphere.
Models suggest K2-18b is likely not a solid Earth-like world, but a mini Neptune with a thick hydrogen atmosphere.
A Hycean world might have global oceans under heavy clouds, with crushing pressures in the deep, and
if life exists there, it might be microbial in a dim ocean, powered by chemistry and faint light from a cool red star.
Astrobiologists study how life could arrive in such conditions. On any world, chemical disequilibrium can be created by both geology and biology, so the challenge is to separate the two. Earth's atmosphere have its own biosignature mix, oxygen, methane, and trace gases that would look odd from afar.
The entire game is matching models to spectra, imagining possible atmospheres, and seeing which ones recreate every bump and dip we see in the data.
Many ideas fail, a few survive. Right now, a Hycean-like atmosphere with certain gases fits best, but plenty of details are still fuzzy. That's where Universe Unlocked comes in, taking this complex web of chemistry, physics, and statistics and turning it into a story you can follow.
Over a decade,
K2-18b has gone from just another exoplanet.
Even before Webb, Hubble data hinted at water vapor, suggesting that this sub-Neptune might have a significant amount of water in its atmosphere.
Webb took the story to a new level, going beyond, could there be water, to what exactly.
Red dwarfs can be active, sending out flares that can strip atmospheres or change chemistry, making habitability a moving target over billions of years.
K2-18.
Valence. Thick clouds and aerosols can mask signatures of deeper layers, adding yet another layer of complexity to.
If there is a deep ocean beneath that haze, the life there, if it exists. In the lab, researchers test how exotic atmospheres behave, asking which chemical signatures could only reasonably be explained by biology.
Supercomputers crunch through millions of possible atmospheres, trying to reach not just one DMS.
The story of K2-18b lives in that tension between excitement and skepticism, headlines and hard data.
On Universe Unlocked, we don't need to oversell it. The truth is already wild enough. A planet we can't see, but whose air.
When you look up at the night sky, you won't see K18, but it's there, a faint red sun with.
Thanks to telescopes like Hubble and Webb, that distant dot now has a personality.
Some memes, some videos call it better than Earth, but for humans it would be anything but. If it's friendly to life, it's.
With crushing pressures, thick hydrogen, and no solid ground like we know it, K2-18.
If alien microbes do exist there, they might use chemistry we've never seen, living in a world of red twilight and high-pressure seas.
But we have to be honest. The DMS and DMDS signals are still tentative. Some analyses support them,
Right now, the best answer is maybe. Enough to justify more observations, but not enough to claim alien plankton with a straight face.
More Webb time is already being used to refine K2-18b's spectrum, reduce noise, and confirm or refute those tantalizing hints.
Ground-based giants like the extremely large telescope will also join the hunt, measuring exoplanet spectra with unprecedented resolution.
Future missions like the Habitable Worlds Observatory aim to go even further, directly imaging Earth-sized planets.
K2-18b is just one piece of a much larger puzzle. How many different ways can a planet support?
Out of thousands of known exoplanets, only a handful are close enough, big enough, and well-placed enough for Webb to probe their atmospheres in detail.
That makes each one precious. K2-18b happens to sit in a sweet spot for observation, even if it isn't a comfortable clone of Earth.
Behind every plot and model are people, students, postdocs, scientists, arguing with the data,
Conferences now include entire sessions on K2-18b, where experts debate everything from its ocean depth to the chemistry of potential metabolisms.
Our job at Universe Unlocked is to translate that debate into something you can follow and enjoy, without sacrificing accuracy.
Maybe you're watching this from a city balcony, wondering if you'll one day help design the missions that answer these questions for real.
If that excites you, you're in the right place.
K2-18b is not Earth 2.0. It's something stranger, a hybrid between a
measures. We know its size, mass, orbit, and several atmospheric gases. We hope to learn whether its chemistry is stable.
In theory, far future missions could one day send probes or even tiny interstellar sails to worlds like this, sampling their atmospheres directly.
Fast, lightweight probes one day skim through alien skies. For now, though, our best tool is Webb, quietly listening to the faint fingerprints of molecules.
Each spectrum is a barcode for a world. K2-18b's barcode.
Even if K2-18b turns out to be lifeless, the search itself is changing how we see our place in the cosmos.
Studying distant planets also teaches us how unusual our own world is, and which fingerprints of life we should look for elsewhere.
Earth and K2-18b are two very different experiments.
If the DMS signal holds up, K2-18b might mark the...
Whether that hint survives the next round of data or not, we'll be here following the evidence, updating the story, and unlocking each new piece with you.
Right now, the most accurate label for K2-18b is simple: under investigation. And that's exactly where the frontier of science lives.
You don't need a lab coat or a telescope to be part of this. Just curiosity and a willingness to follow the data wherever it leads.
From K2-18b's possible ocean to other strange worlds and megastructure ideas, somewhere among those stars, something is breathing, reacting, or evolving. Whether on life on K2-18b? Maybe. The only way to know is to keep asking hard questions and building better tools to answer them. If you want to follow that journey with us, from first hints to real answers, hit subscribe and help us unlock the universe together. This has been James Webb's Ocean World, K2-18b, seen through the lens of Universe Unlocked. Because in the end, the universe only becomes unlocked when curious minds like yours dare to turn the key.